Alright, so again, this is a very short unit. Day 1 was trig derivatives. Day 2, which is today, trig integrals. So we are going to learn our basic trig integrals, and then we're also going to take a look at how to integrate. Sometimes we have to use U substitution, bring in all the integral stuff that we did last unit as well. So we've got total change, the area under the curve, all that comes with it. So this first part of our notes is exactly what you saw in last class's notes. Just a reminder from our fundamental theorem of calculus, derivatives and integrals are inverse operations. Last class we focused on our derivatives. This class we're focusing on our integrals. So the right side here. Alright, so again, this very first thing, when we see that there is some type of chain rule happening, we have to use U substitution to help us evaluate that integral, to help us find that antiderivative. And so we are going to continue with U substitution. Again, we're integrating with the same rules that we did before, but now we have some trig functions that we know these integrals for. Alright, so again, antiderivative is that function before that will give you this derivative sign. So my integral of cosine, or the antiderivative cosine, is just sine. Again, because the derivative sign is cosine. So the integral of sine then is negative cosine. Why do I have that negative there? Yeah, when I took my derivative of cosine, that gave me negative sine. So if I'm integrating just a regular sine, that means I need to have opposite of that original function here. So if I were to take my derivative of negative cosine, that would be negative sine, which gives me that positive sine. Alright, integral of secant squared is our tangent, integral of secant tangent is secant, and then integral of cosecant squared is, again, that negative cotangent, and integral of cosecant cotangent is a negative cosecant. So probably the trickiest thing with this is remembering those negatives when they pop up. And again, it all comes back to, do you know your original derivative is or not? Alright, we're just going to go ahead and dive on into some of these problems down here. We'll use that to refer to, but if you know your derivatives, you know your antiderivatives. Alright, so our first problem, again, same rules as far as our coefficients and constants go. So here I have a coefficient of 2. This is the same thing as just bringing that 2 out in front. Just like before, we can take any of those coefficients that are being multiplied and just bring them out in front. And what is the integral of cosine? Or antiderivative of cosine? Sine. So I have 2 sine x, and this is an indefinite integral, which means I need plus c. Good, plus c. So indefinite integrals, we still have our constant, that plus c at the end. Alright, now we didn't need to use U substitution here because we just had a simple basic function of x. We didn't have anything more than x within there. Alright, number 2 though, we do see we have something more than just x. We have sine of 4x. So we do have something more than just x within there. So we are going to want to use a U substitution. So let U equal 4x. I'm going to warn you guys, you're going to want to write decently small for this. I went back there and tried to respace out the notes a little bit better, but you will want to write a little bit smaller for this. So U equal 4x, what would du be?
4.
Good, 4 dx. And if I look, I have dx, but I don't have a 4, so let's go and solve for dx. What would dx then be? Good, du over 4 or 1/4 du. Either way is fine. Alright, so when I go ahead and rewrite this in terms of u, then I'm going to have the integral. So instead of sine of 4x, I'm going to have sine of u. And then 1/4 du, I'm going to go and pull that 1/4 out in front. 1/4 du. And now we just integrate like normal. So I have, again, 1/4. And what's the antiderivative of sine? Negative cosine. Don't lose that, so I'm going to throw the negative in front. Cosine of u. Are you guys okay if we just go and replace the u right now? Okay. So cosine of u, which is 4x. And then let's see. Okay, so U substitution is still done the same way. You might find that you have U substitutions a little bit more often with trig. because as we had before, we had chain rule happening. Alright, questions with that one? Okay. I want you guys to go ahead and try number 3 then. The integral of cosine of 1/2 x dx. And again, note that my argument is 1/2 x, so I am going to need to use the u substitution because there is something more than x there. So go and give that a try. Alright, when we did our u substitution, did we get the integral of cosine u du with a 2 hanging out? Okay with that? Alright, and antiderivative, so 2 just comes along for the right. What's my antiderivative cosine? Good. So sine u, again I'm just going to go replace that. So sine of 1/2 x. Don't forget that plus c. Questions on that? Number 4, so we have sine of x plus pi over 4. Do you guys remember your sum and difference rules? Do you have a question?
Yeah, we were taking the derivative of 1/2. Oh,
You good? Okay. So number 4, we have sine of x plus pi over 4. Do you guys remember your sum and difference rules? No? You should remember those, but don't worry, you don't have to use it for this one. So don't forget your sum and difference rules. You never know, they might throw that at you. But we don't have to use that for this one. We still just have something more than x happening here. So we're still just going to let that be my u.
Oh, I'm sorry. Oh, what happened to the negative? So, like, why isn't it negative sine?
So what is your derivative of sine?
Oh,
Just normal positive cosine, right? And guys, that's good to do. When you finally find your antiderivative, just real quick, double check. Derivative of cosine is negative sine, so I would have negative of a negative would give me that positive there. Derivative of sine is cosine, so I have that positive cosine. So just do a double check to make sure you don't neglect this. Okay, so for number 4 here, we're going to go ahead and let u be that inside there. So let u be x plus pi over 4. What would du be? What's du going to be for this thing? Yeah, just 1 dx, right? Derivative of x is just 1, derivative of pi over 4 is nothing. So then I can go ahead and rewrite this, the integral of sine of u du. And my antiderivative of sine is negative cosine, good. And again, just throwing back in that u, negative cosine of x plus pi over 4 plus c. That's what I'm saying. Questions with that one? Now, take a look at this problem. Yeah, we had something more than just x within there, but would chain rule have really affected us with this problem? If I would have had to, so taking a look at what our answer is here. When I do chain rule, what is the derivative of that inside? Just 1, right? And when we multiply by 1, that doesn't affect our problem at all. So even though we had something more than just x, my derivative of that inside was still just 1. We honestly could have bypassed the u substitution here. If you look at this and recognize, hey, chain rule is not going to bother us here, so what is my antiderivative of sine? Negative cosine, inside stays the same, and you're good to go. But with number 3, we do have something more than x, so we do need to counteract that. But if I had my chain rule here, what would be the derivative of 1/2 x? Just 1/2, right? Derivative of 1/2 x is 1/2. Are we okay with that? Okay. But we know that with our integral, we'd have to counteract that. What counteracts the 1/2? 2. Notice how that popped up here. Likewise with number 4. If I did the derivative of my inside here, what would be the derivative of the inside? 4. How would we counteract that? 1/4. No, that's what happened there. So U substitution is necessary, but when we have where it's just a coefficient, if you're able to mentally bypass that U substitution and go straight to your antiderivative, that's fine. Now, if that confused you, that's too much for you to handle in your head, that's okay. Just do a quick little U sub and you'll get there. But by the end of today, you might be like, all right, I got this, Mr. Margraf. If this was sine of 5x, I know it's going to be negative 1/5 cosine 5x. Okay, so again, it's just that coefficient, not an x squared, but just like 5x or 10x. And you're able to skip those steps, go to your answer, that's fine. Yes?
So on an AP exam, we don't have to put like U equals?
Nope, not if it was a problem as simple as that, yeah. Honestly, for a response for AP exam, it wouldn't be that simple. But if they were to have to give you one, yeah, that'd be fine. Yeah, it's kind of a small enough use of that it's trivial, so you're able to do that mentally. Other questions with that? Okay, so let's take a look at actually which one I want to do next. Oh, we definitely want to do number 7, but I think I want to go to number 6 next. Alright, so number 6, we have 3 sine pi over 3 minus x dx. Alright, again, we have something more than just x happening within here. I'm going to go and stick with the u sub, just so I don't lose anyone with this. Now, again, what can I do with that coefficient when it's sitting in front? What can I do with it? Yeah, just break it out in front of that whole integral. So keep that in mind. Let's go and identify our u sub. I'm going to write this smaller here. Alright, so let's let u equal pi over 3 minus x. Now be careful, what is my derivative? What does du equal? Negative 1 dx, good, or even just negative dx. Don't lose that negative there. Alright, so taking a look back at my original, I have the dx. I don't have a negative though, so let's go and just solve for dx. Do you guys agree dx would be negative du? Are we okay with that? Alright. So now let's go ahead and write this in terms of u. So I have that. I'm going to bring that 3 out in front. Integral of sine of u dx is negative du. I'm going to bring that negative completely out in front. Are we good with what I just did there? Integral of sine of u du with the negative 3 sitting in front. Any questions with that? Okay, so now let's just go and integrate. So negative 3. Antiderivative of sine u is negative cosine. I'm going to go and just write this out. Negative cosine of u plus c. So negative times negative is going to be a positive 3 cosine of pi over 3 minus x. Plus, and that's your answer. Questions with that one? Again, if you're able to recognize that the derivative of my inside here would be a negative 1, so we would need a negative to counteract that, and thus you would have gotten to your negative 3 negative cosine mu, and then some derivative. Alright, number 7. What's the antiderivative of secant x tangent x? What's the antiderivative of secant x tangent x? At first it looks like some type of product, right? But what derivative gives me secant x tangent x? Yeah, if we take the derivative of secant x. So this is actually just a straightforward one. Derivative secant is secant tangent. So don't let the product there throw you off. Just think real quick, does that match up with any of my antiderivatives? Alright, what's the antiderivative of cosecant? Good. So if we look back up here, cosecant squared, negative cotangent. Again, we didn't have to worry about a u substitution here. This is just a straight antiderivative. So integral of cosecant squared is negative cotangent x plus c. And again, just do a double mental check. Derivative cotangent is negative cosecant. The negatives would cancel out. Or secant is secant. All right. I want you guys to go ahead and try number 5. So we don't leave it unfinished. Yes. Yes. Simplicity.
Switch it out and put it
I like it.
It's harder anyway.
Get 1/2 sine 2x minus 1 plus c. Good. Do we need a negative here? Nope. Direct sine is cosine. Good. All right. Let's move on to bigger, better things. Let's do. Let's take a look at number 10. Alright, so number 10, we have 4 over sine squared x. Do we know the antiderivative of a sine squared? No. We know antiderivative is sine, right? So, I mean, we could rewrite that as 4 over sine times sine, but again, we don't have a product rule or a quotient rule when it comes to integrating. We could try u substitution. Don't write this down, because u substitution doesn't work, but I'll show you why. So if I try to use substitution, let u equal sine x, what's my derivative then of sine x? Cosine x dx. Is there any way I can bring a cosine into that integral without messing with it? No, so u substitution's not going to help us out here. Because although I have a function inside a function, I don't have that derivative represented within my integral. So u substitution is not going to help us out. Any thoughts as to what we can do? We don't have a product rule. We can't use u substitution.
Bring it to the numerator.
Okay, so you want to bring it to the numerator and take out the 4. When you say bring it to the numerator,
So
what do you mean by that?
4 times sine x to the negative 7.
I like what you're thinking, but we have to go about it a little bit different. So this is going to be the integral of 4 times, are you guys okay if I write it like this? Actually, yeah. I don't actually think that was the Are you guys okay if I rewrite it like this? You good with that? Now, the reason why I'm going to rewrite it like this is this might help you kind of recognize, what was that 1 over sine? Cosecant, right? So would you agree that 4 over sine squared is 4 cosecant squared? Right, so that's what Amelia was saying, but we don't want to think of it in terms of a negative to exponent, right? Because we've got to be careful with our trig. We don't have negative exponents, we have reciprocal functions. And that negative 1 is reserved to represent inverse sine, okay? So we don't want to write this as sine x to the negative 2nd power, we want to think of this as cosecant x squared. Does that make sense there? Questions on how we got to this? Good with that before we go. Okay. So now it's a lot easier for us to handle. So again, that 4 can come out. What's the antiderivative of cosecant squared? Good, negative cotangent. I'm going to throw my negative in front there. negative cotangent x. And then we're done. Questions with that? So then let's go and take a look at that one next, or just kind of re-emphasize that. So again, 1 over cosine squared. Let's rethink of that as 1 over cosine quantity squared. So how could I rewrite this using the reciprocal identity, or the reciprocal function? Good, very good. Secant squared. So this is going to be secant of 4x plus 1 squared dx, right? So again, we want to think of it in terms of that reciprocal function. We can't use u sub here. It's not going to get us anywhere. We don't have a product rule for integrals, so we want to think of our reciprocal functions. What's the antiderivative of secant squared? Ooh, what derivative gives us tangent? Good, good, good. So we've got tangent. All right, but my inside was 4x plus 1. How can I counteract that? Ooh, can we do the shortcut without the u sub?
What do you mean? Counteract?
So if I were to right now take my derivative, I would have secant squared of 4x plus 1 times 4, right? My 4 is not represented in my original integral. So chain rule would require us to multiply by 4. But we didn't have 4. So what would counteract multiplying by 4? 1/4. Okay. So we would have 1/4 tangent of 4x plus 1. That's bypassing the u sub. Let me go ahead and do the u sub because I see a lot of you that are looking at me like I'm crazy here. I mean, that might be true in some cases, but right now it's not. So if I let u equal 4x plus 1, let me squeeze it in better. Let u equal 4x plus 1. So du would be 4 dx, which means 1 du is dx. So if I did my u sub, I would have 1/4 the integral secant squared. 4x plus 1 is u, du, right? So 1/4 du equals dx. I went ahead and brought that 1/4 out in front. Are we good with that in our u sub? Questions on that? Okay. So then I go ahead and do my antiderivative. My antiderivative secant squared is tangent. And then throw back in what u was. 1/4 tangent of 4x plus 1. And notice that this matches with what we did. So what I did in blue is I kind of mentally did that u sub where I just simply counteracted what would have been the derivative with that 1/4. Again, if that's too much for you, that's perfectly fine. Do the u sub, just a quick u sub off to the side. You can get the same answer. All right, questions with number 11 there. All right. I want you guys to go ahead and try number 12. Notice that this is now a definite integral. So we have actual bounds here. We do this the same way that we did before. Find your antiderivative and evaluate it from 0 to pi over 2. So go ahead and give that a try. It's a basic, not too bad antiderivative. So go ahead and try that one, and we'll see how you do with that. Feel free to check those around you as you're working on it, just to make sure you're on the right track.
It's like I know it's happening, fast, but like it's coming.
Alright, so remember this is a definite integral. If we simplify it all the way down, we should get down to a single value. Alright, first let's check to see, can I do my antiderivative of cosine? Yeah, what is antiderivative of cosine? Sine x evaluated from 0 to pi over 2. And this is where knowing that unit circle is very important, right, Gerard? Yeah. So we have sine of pi over 2 minus sine of 0. Gotta know your unit circle. What is sine of pi over 2? Sine of 0? So we should have gotten inches. Raise your hand if you got that. Questions on that one? Yes. Yes, yes. That's probably more proper. Alright, so let's take a look at number 13. Now you should have extra space off to the side if need be. So number 13 here, notice we do have something more than just x inside. So if you need to do that u sub, go ahead and do so. I'm going to go and do it up here. So let u equal 2x, right, because that's my entire argument there. Du would be 2 dx. And I see dx is represented, but no 2, so I'm going to go ahead and divide out that 2, so I have 1/2 du equals dx. Are we good with that u substitution here? Questions with that? Okay. Now, if I'm about to do u substitution, I not only need to change my variable to be u and my differential to be du, but what else do I need to change? Yeah, the bounds. We have to change those bounds. Don't forget to change your bounds. All right. So u of pi over 6, and I need u of 0. Alright, when I take pi over 6 and put it in, what does that simplify down to? 2 times pi over 6, what's that give me? Good, pi over 3? Very good with that. So 2 pi over 6, which reduces pi over 3. And then when I take 0 and put it in, what do we get? 0. Yeah, we just get back 0. Alright. So let's go and rewrite this. So we have the integral. We're going from now 0 to pi over 3. Sine of u, and dx is 1/2 du, so I'm going to bring that 1/2 to the front. Du. Are we good with that u substitution? Yes. Yes, yeah, when I'm finding my new bounds, I take those bounds and put them into u. Because right now this is bounds of x equals 0 and pi over 6. So when x is 0, what is u? And when x is pi over 6, what is u? Other questions before we evaluate this guy? Okay. So my antiderivative of sine u would be what? Antiderivative of sine. Negative cosine, right? So I still got 1/2. My antiderivative of sine is negative cosine, evaluated from pi over 3 to 0. Are we good so far? I want to make sure we don't lose anyone along the way. Okay. And then let's go ahead and evaluate. I personally would like to bring my 1/2 and the negative together, so I'm going to leave my negative 1/2 out. So I have cosine of pi over 3 minus cosine of 0. Now you are more than welcome to distribute that negative 1/2 in there. What I have found with trig is that it seems to be easier to leave the coefficients sitting out in front, simplify the inside, and then distribute out, but it's totally up to you. Alright, so again, going back to our unit circle. What's cosine of pi over 3? Very good. And what's cosine of 0?
1.
Ooh, is it 0 or is it 1?
1.
1, good.
0 plus.
Big catch. Alright, so we have 1/2 minus 1, which would give me a negative 1/2, right? So do we agree with positive 1/4 overall? Hey, you sound so thrilled.
Oh no.
She's Speedy McSpeedster back there. Questions on that one? So really not too bad, right? So far, still not too bad. It's same as before, just you need to know those derivatives and antiderivatives. All right, let's find one that's a little more complicated. Yeah, we've got some good ones. 15, 16, 17 are all good. All right, let's take a look at 15. Let's talk about 15 for a moment. So 15 here, we have cosine 2x and sine 2x. We are meeting a new world of u substitution. So far, we've been dealing with u substitution only when we had a single trig and there was something more inside of our argument. But here we have multiple trigs happening. Remember, we don't have a product rule when it comes to integration. But we can be decisive, or we can be wise as to how to choose our u substitution. So with u sub, again, we now have the option of something more than just my inside. We see that our insides are 2x, right? So if I let u simply be 2x, and I'd have cosine u sine u. And do I know how to integrate cosine sine? No, we still are stuck. So let's actually... Okay, I'm going to put back in my parentheses. Instead of choosing just my inside argument, let's let u be... Do we want it to be cosine or sine? I think sine, so we don't have to do it with negatives, right? Okay. So let's let u be sine 2x. What would du be? Cosine 2x times 2 dx. Do we agree with that? Remember, we're taking the derivative here. So derivative sine is normal cosine. But we did have to follow chain. Are we good so far? Are we together?
Wait, why didn't we just multiply the du with the 1?
We're going to. So we're going to solve. We still have some more work to do. Yeah. We still have some more work to do, but are we okay so far? Okay. So now watch. I think this is so cool. So I'm going to let u be my sine 2x, right? That's taken care of. Now, if I look at what's left behind, I had dx and cosine 2x. Oh, look. Dx and cosine 2x. Isn't that convenient? So I already have cosine 2x dx represented. So let's go ahead and just divide by that 1/2. So I have 1/2 du is cosine 2x dx. Do we agree with that statement there? So now when I go ahead to rewrite this, we're going to have to change our bounds. But I want to just make sure we're good with rewriting this part of it. Cosine 2x dx, what did that equal? The cosine 2x, 1/2 du, so I'm going to bring my 1/2 out in front. Du. So I took care of the magenta. And then what did we say sine 2x is? Just u, right? Not so much easier to integrate. Now, we do need to change our bounds, so let's go ahead and do that. Well, there's not much room. All right, u of pi over 4 and u of 0. All right, pi over 4 times 2 would be pi over 2. What is sine of pi over 2? 1. And sine of 0? Oh my goodness, this is going to be so nice. Look at that, from 0 to 1. So we just took that crazy complicated integral and turned it into a much nicer one by using u sub. Okay, so you can use u sub to help you tackle trig when there is, oftentimes it's when you have some type of product that's not already an antiderivative. All right, so now let's go ahead from here. What's my antiderivative of u? U squared over 2. Do you remember that? So just normal integration that we used to do? From 0 to 1. Are we good with what happened?
Yeah.
Okay. You just had me a little worried for a moment. Again, I'm going to go ahead and multiply that 1/4 together. So then I have 1/4 times 1 squared is 1. 0 squared is 0. So what's my final answer? Just 1/4. How crazy is that? So again, you brought this into a much more manageable state. Questions with that? Now I want to show you another way that we could have done this by using our trig identities. It's kind of a sneaky way. You don't have to write this down if you don't want to. It's up to you what you want to do with it. All right. So we had 0 to pi over 4, and then was it cosine 2x, sine 2x? Yes. Is that what that problem was?
Yeah.
Okay. Now we can actually be kind of sneaky here. When we have sine times cosine, what is that similar to? Not exact, but close to. Our double angle identity for sine, right? So just a reminder that sine of 2 theta is sine theta cosine theta. Or sorry, man, I did that last time too. It's 2 sine theta cosine theta. Do we remember this? Our double angle identity? So watch what sneakiness we can do here. What am I just simply missing to have a match? We just need a 2, right? Well, come on, we are so good with doing some fancy algebraic footwork. I need a 2. But I can't just throw a 2 in there. How do I counteract that? Isn't this great? So then I have 1/2 the integral from 0 to pi over 4. Now, what would this simplify down to? Be careful with. 4. So we would have, we have our 2, so it's sine of double our angle. So double of 2x would be 4x, right? Are we good with that? You see what happened there?
No.
If I have my theta is simply 2x, right? So sine 2 theta would be 2 times 2x. Does that make sense? You double your angle. That's why it's called double angle identity. So whatever your angle was, it gets doubled. Okay? Now this is a bit easier to go ahead and evaluate from here. I could do a small u sub where we let u go back to being just the 4x. du is 4 dx. So 1/4 du is dx. So then I would have 1/2. I'm going to go bring my 1/4 as well, so let's go 1/8. Change my bounds. U of pi over 4. U of 0. What is u of pi over 4 going to give us? Pi, right? And what would 0 give us? 0. You right back there, Bart?
Yeah.
Okay. Alright, so we have 0 to pi. And this is sine of u du. And my antiderivative of sine? Close. Negative cosine. Evaluated from 0 to pi. So negative 1/8. What is cosine of pi? Ooh, we're going on the other side of our unit circle. What's cosine of 1? Negative 1. And cosine of 0? 1. Are we good so far? Libby?
I think you had 1/8.
Oh, so I had 1/2 times 1/4, because the 1/4 came out from my du. And then I went ahead and just multiplied those together. I did a couple steps. Alright, so we get negative 1/8 times negative 2. What does that give me? 1/4. Now, it seems to be about the same amount of work if we look back and forth between them. But that is an alternate way to go about it. By rewriting it first as that double angle. Oh, whoops. And then evaluating from there. So, up to you. But I just want you to know. Yes?
Is there have to be written like a cosine?
Oh my goodness, I lost my variable. Thank you. That was bad. Other questions? So my antiderivative sign is negative cosine, so I just went and brought my negative with the 1u. Other questions with this? Okay. I think, let's take a look at 16. And I don't want to do it all of I mean, I enjoyed it, but I've already done it. Yeah, let's take a look at 16. I forgot about this. Alright, so number 16, we have tangent squared of 1/2 x dx from pi over 3 to pi over 2. Alright, now my argument is 1/2 x, so there's something more than x, we probably have to do u sub with that. Do I know an antiderivative of tangent squared?
No.
Yeah, if we take a look back at that very first page, I don't see tangent squared anywhere here. Alright, there's no tangent squared. So we're going to have to do something before we can evaluate this integral. Alright, now I could rewrite this. You don't need to do this because this is not going to help us out, so I don't want to show you why. I could rewrite this as tangent of 1/2 x quantity squared. But again, doing a u sub here, if I let u equal tangent of 1/2 x, my du, what's derivative of tangent? Secant squared. Got to make sure we know our derivatives and antiderivatives. I'm not going to be able to bring that secant squared in somewhere. So doing a u sub here is not going to be beneficial for us. So we can't do u sub. I don't know the antiderivative. Any thoughts of what we can do with this step before even taking? What do you say? Good, let's take a look at that. Can that help us out? Sine squared 1/2 x over cosine squared 1/2 x. Can that help us out? Could I do a u sub with that? Possibly. If I did a u sub with this, we would let u be, honestly, you could pick either one here. I would probably go ahead and pick the denominator. But let's see if that would even help us out. Let u be cosine squared of 1/2 x. What would du be then? Wouldn't we have to do power rule with that? Yeah, because this is same thing as cosine of 1/2 x quantity squared. So we'd have to do power rule with chain rule from the inside there. And that, unfortunately, doesn't help us cancel out that sine squared. So another great idea, but unfortunately won't help us out. So we can't do u sub straight up. We can't do just regular antiderivative. Sine squared over cosine squared doesn't help us out. What do we have left in our toolbox? What do I have? Oh, no, not calculator. Our brains can handle this. If it was a calculator section, then please use your. What else do we know? What do we know?
Split it up.
Split it up, tangent times tangent. I like that, but again, we don't have a product rule with that. Tanisha, can you please say that loud for all to hear? I'm glad you had the same reaction I did. 1 minus secant squared. Do we agree that we can make that substitution? Does anyone need to see how we know that substitution? Sure, we're good, because I love that Pythagorean identity. I will derive it for you. Okay. So we have sine squared plus cosine squared equals 1. I need tangent squared. Tangent, if I divide everything by cosine, which agree we get tangent. So divide both sides by cosine squared. So I get sine squared over cosine squared is tangent squared theta. Cosine squared over cosine squared is 1. 1 over cosine squared is secant squared. Go with that. So secant squared theta is equal to, I meant tangent squared theta is equal to secant squared minus 1. Do we agree with that? Isn't it wonderful how we can derive so much math with just a little bit of math? Alright, so if we make this substitution, do I know the antiderivative of secant squared?
Yeah.
Do I know the antiderivative of negative 1?
Yeah.
Yeah, so now that's finally something we can handle. Alright, so now let's write this down. Let's rewrite this. Pi over 3 to pi over 2. Instead of tangent squared, what was it? Secant squared minus 1? Is that what we said?
Yes.
Okay. Oh no, not theta. Yes. I love theta as well. Let's go over here. I'm going to go and put a... So tangent squared is secant squared minus 1. Now we can go ahead and do a u sub from here and do our antiderivative from that. I'll let you guys do that as part of your homework. But that is our setup for it. Are we good with that? Are we good with what happened there? Any questions? Okay. I think I want to take a look at number 23. So again, as you're doing these, look to see, is u sub going to help you out where you let u be an entire trig function? Or is there a way that you could rewrite it to make it something a little bit more manageable? Hint, hint, wink, wink for number 17. Could you rewrite that in some shape? Okay, 23. So this is an interesting one. We have x sine cubed cosine. All right, what is that? Again, anytime you have a trig function that's to the power, let's go ahead and rewrite this. Oh, good, we're back to indefinites. Those definites are smart.
Yeah.
So I have sine of x squared, that quantity cubed, and then cosine of x squared. Okay, so always rewrite that with that power. Okay. I mean, I see sine, cosine. I could maybe do a little bit with the double angle, but I don't think that's going to make it any simpler for me. Let's see if u sub can help us out. Because right now we don't know this antiderivative, right? There's just way too much happening. But let's try u sub. Notice that we have x squared inside, so that's a possibility. We have both the sine and cosine, so we could let one be one or the other. But we also have that a sine x squared is inside of the quantity cubed. That's kind of a lot happening there. I say let's try letting u be that. So let u be sine x squared. Right, so I'm letting u be this entire inside piece here. Which would give me u cubed there, which is much more manageable. So we've got to make sure that its derivative is represented. So what would be the derivative of that? So we've got cosine x squared times the derivative of the inside, which is good, 2x. Okay, over 2x. All right, which pieces of that do we actually have up there? Good. Cosine x squared dx. Is the x represented up there? Perfect. Perfect. So we've got our cosine x squared, we've got our dx, and we have our x. So we only need to deal with that too. So I could say 1/2 u is, I'm going to go and rewrite that x in front, just so we can have this a little bit better. X cosine of x squared dx. Do we agree with what happened there? Questions and what? Okay. So So this is where u sub was actually beneficial for us to choose the inside function. And again, what clued me in to do that is I don't already know an antiderivative. I don't have a nice, simple trig substitution with identities I could do there. And to have sine raised to a power, I know that the derivative sign is cosine, I said it kind of represented there, so that gave me a hint there. Okay, I've got a function within a function. Let's try that. Okay. So now, oh good, that's right, no bounds. Let's go ahead and replace. So x cosine x squared dx. We said it was 1/2 du. I'm going to bring my 1/2 out in front. Stick my du on the end. And then sine x squared is just u, so I have u cubed. So that crazy thing with their use of brought it down to something much more manageable, 1/2 integral u cubed. Questions with that so far? Okay, so that's going to do our antiderivative. What's the antiderivative of u cubed? Good, u to the 4th over 4. See? And now let's go ahead and do some resubstituting in to make it nice and neat. We're going to go multiply my 1/2 and 1/4. I'm going to write that 1/8. And my u was sine x squared. So do you agree it's sine the 4th of x squared plus c? Again, you could rewrite this. You could have written this as sine x squared quantity to the 4th. I just want to write the power. Are we okay with that? Questions on that? Okay. What do you guys want to do? We still have time for one more problem. 28 or 29? Just 29? 29 is too easy. Let's do 28. Oh, shoot. Oh, no. I meant to fix the number and I forgot to. Oh, it took off 28. Okay, good. Yeah, let's do 28. There was 25. So you'll see on the key on Blackboard, there were some that were omitted, and I hated that that space was sitting there taking up valuable space that you could have used for your problems. So I reformatted it to try to give you more space. All right, 28, we've got square roots. All right, so I have cosine of square root of x, and I also have square root of x in my denominator. Should we try letting u be the inside there? Let's see what happens. Let u be just my inside, so x to the 1/2. Du then would be what? 1/2 x to the negative 1/2 dx. Are we good with that? Now that's encouraging for us because what does x to the negative 1/2 mean? Yeah, square root of x where? In the bottom, and don't we have that? So that's good, that's what we wanted. Also, when you let u be the inside there, you're not letting it be a trig, so we don't have a trig in my du, so you don't have to worry about extra trig that you don't need. Alright, so let's go ahead and rewrite this. I think we just need to move the 1/2, right? So 2 du equals x to the negative 1/2. Are we good with that? Okay. So let's see what we've got. Cosine of square root of x becomes cosine of u. And then x to the negative 1/2 dx. I have my dx. And do you agree that this square root of x in the denominator is the same as x to the negative 1/2? Are we fine with that? So let's just replace that with 2 du. I'm going to leave my 2 out in front now. And then let's integrate. What's my antiderivative of cosine? Let's see. Now, again, real quick check. Derivative sign is cosine. Just make sure you got those signs. And then just put your u back in. And again, you are welcome to go and substitute your u in there. And you could rewrite that as 2 sine square root of x. Questions with that? We still have like half the problem. Okay, so your homework is going to be to finish the prompts in this packet. Yours does not have a back page. So again, this is a very short unit. Next class, we will do just some more with our trig, specifically more with our derivatives of trig. But keep in mind, also guys, you'll notice on that assignment sheet, if you know that you're going to be gone the day of the test, please let me know so we can schedule makeup for you before you leave for break, so you don't have to worry about studying all over break to remember that after break. Because if you miss the test, the day I see you after break, you get the test. Yeah. Yeah, so I would see you on the 15th anyway. Yeah. Then I'll just have to do it during class the 15th. Does that work for you? Unless if you want to come after school on that day or after school. Right, yeah, so let's talk about it that week and see if after school works better. But if not, we'll see you Friday, so we can just do Friday.